Hello and welcome back to week 7 of the SAS Bootcamp. This is the last week of the bootcamp, and really, this is the last week of content that you will have to watch as part of this bootcamp. And this week actually is also one of our most important weeks, which is why I've gotten through 6 weeks of this bootcamp without ever going to a PowerPoint slide. But this week, I've actually put together some slides for us to talk about this topic. Because this week, we are going to learn programming etiquette, how to be a better programmer. I cannot overstate how important this topic is for any and every SAS programmer. If you have learned even a little bit of SAS through these 6 weeks of content, and you're going to be working on a program, this video is for you. I want you to watch this video and inculcate as many of today's topics into your general habit so that these things about programming etiquette come as second nature to you without having to think too much. The objectives for today's programming, for today's content are here. First, we are going to talk about readability and appearance of your code. We are going to talk about workflow process and analysis planning. We will go over version control and naming conventions. We will talk about programming efficiency and quality control. Now, over the course of the past 6 weeks, I've tried to set an example by showing you guys how to do all of these things. So I've tried to implement as many good programming practices as possible in all of my previous code files in the hopes that some of that rubs off on you as you're beginning to learn SAS right now. Obviously, I am not perfect, so I have not done everything that I think I should be doing, and some things I can always do better. So in this video, we are going to go over all of those things that I think you should be doing as part of good coding practice. And we will begin with readability and appearance. And really, this is the most important thing. I started today's presentation with this topic because if you get nothing else from this video, please get this one. Comment, comment, and comment. Every time you write your code, make sure you leave comments. I try to do this as part of every single code that I've shared with you guys over the past 6 weeks, and I hope that comes as second nature to you. Every time you start a program, set a header. The header should, at the very least, indicate 3 pieces of information. What is the purpose of the program? What is the programmer's name? And what is the date that you worked on? And this helps make sure that when you share your code with somebody, they at least have some context before they jump straight into the code. Next, every time you have a data step or a procedure or a proc SQL or something else, write a simple comment explaining what you are doing, no matter how simple or easy your code is. You might think, you know what, this next step is too simple and I don't have to write anything in a comment to explain it. No, write it anyway, because that is the kind of good habits that will stay with you and come to you as second nature and will eventually pay off towards the end. And if you're writing something that is a really complicated programming logic, whether that is arrays, macros, or whether you're using do loops or for loops, make sure you write in the comments in between your data steps. It's also to help your reader walk through the logic. I've pasted a screenshot here from some of our code from week 1 to give you an idea of what this is supposed to look like. On top of comments, there are many other things you can do to make your code look better and to make it more readable. First, indentations and spacing. Every time I use a loop, for example, I like to indent all of my code within the loop to one step or one tab ahead of the do and the end statements. Because remember, in SAS, tabs and spaces are not meaningful. You can enter as many spaces as you want, and SAS will not interpret them as an error. SAS will ignore additional spaces, basically. So you can enter as many spaces as you want to make your code look readable. And here I've shown an example of what a few lines of SAS code look like if you indent it properly and if you don't indent it properly. Both of these code lines actually do the same thing. They accomplish this task, right? They get the job done, but one of them is a lot more readable and it looks a lot easier on the eyes than the other one. Along with indentation and spacing, some other rules to help your readability are make sure you don't have more than one programming statement per line. That is, every time you hit a semicolon, make sure you hit enter and start on the next line. And then on long projects sometimes, don't just let your whole code file be a big chunk of code. Separate your code out into sections. Your sections can be anything as eligibility section or the analysis section or medication information or cost section. Whatever you split it as, divide it into sections and separate each sections using a bunch of comments similar to what a header will look like, but you don't have to make it as extensive as a header. Just write 2 lines of comments basically saying this is a new section, and in this section this is what we are going to do. And helping to break up your code into sections also makes it readable. Some other things: always format your date variables to be presentable. Always. Don't just default to SAS date, because SAS date is not readable. Do not extend any line of code beyond your screen, usually about 72 to 80 characters. And this is important because nobody likes to scroll horizontally. In SAS, really, you can make a line as long as you want, and that will involve horizontal scrolling when you're reading a code, and that's really not very good. And even if you print out a SAS code file, horizontal scrolling does not actually print out well. So make sure if you have a really long line that you hit enter and pick up on the next line, even before your programming statement is completed. And then the last point on this slide is actually something that I tried to do, and I've tried to set as an example every time I've done programming in this past 6 weeks, and that is distinguish variable names from syntax. This is one of those things that is very subjective and it is personal. I know not many people do this. I really like doing this. I'll go back to my previous slide to show an example. On this slide, you may have wondered why, as I was programming throughout the course of these past 6 weeks, I've used capital or uppercase letters sometimes and lowercase letters sometimes. The reason I do that is because as you begin to learn programming, it is very helpful to know what words are actually part of the SAS syntax versus what words are part of the file names, variable names, and other things that are user generated. The way I distinguish them is by using uppercase letters for the SAS syntax, like data, set, by, retain, if, not, then, so on and so forth. And for all of the dataset names like drug cost, NDC underscore FAT 690, these are all dataset names. I write them in lowercase letters. Now, of course, SAS will actually show these things to you using these formatting that SAS has inbuilt in the blue letters that you see. But as you should know by now, SAS formatting is not always perfect. Once you get into macros, once you get into arrays or loops, the SAS formatting is not perfect, and SAS actually does not format something as blue, even if something is part of the syntax. And to avoid those nuances, I prefer doing it this way. This is a particularly useful way if you're just beginning to learn SAS, but I will admit that over the past 1.5 to 2 years, I've observed that the more I try to maintain this kind of difference between uppercase and lowercase letters, I'm beginning to get carpal tunnel syndrome. So I might be going easy on this in the past year or so, but this really helped me as I was beginning to learn SAS, because I could easily look at a piece of code and I could tell what is supposed to be part of the syntax and what is supposed to be just a variable name. Okay, so that's readability and appearance. Next, we'll move to workflow and analysis planning. Once your code looks good, that's not enough to start programming. Before you start programming, you have to plan out your approach for how you're going to do the programming. And the best way to do this is to work your way backwards, right? So before you start your before you start your project, the first thing you need to ask yourself is, what statistical analysis do you need to run at the very end of this project, right? So imagine yourself at the end of the data management work, and what is that data set look like? Once you know the statistical analyses, you need to understand what are the requirements imposed by the statistical analysis. So does your data need to be in a long or a wide format? A long format is typically what is called when each beneficiary or individual or respondent in your data set may be present in more than one row, right? And that duplication is required by some statistical techniques. In some statistical techniques, you need the data set in wide form, which means only one row of data per each individual in your data set. So if you need to imagine that analysis data set, and then you need to envision how to get there to that data structure and those variables based on your input files, right? What I like to do, especially if you're a beginner programmer, is to map out that strategy of how to reach that goal. And to show an example of what that map would look like, I've actually put one together for the week 6 homework. If you remember our homework project, which was a hypothetical outcomes research data set from week 6, I've actually tried to demonstrate what a map would look like if you were to put one together before you start working on this project, right? And let me walk you through this really quickly. On the left here, you'll see that there is a patient info data set, which is our original file. We do an enrollment check on it, and then we left join hospital claims to get eligible hospital claims, right? So we do the enrollment check. And then we use left join to pull claims for all the individuals that are eligible only. And then we do a diabetes check to get our eligible population. Now, I've indicated this little person here because I want to say that this was a claim level file, but this was a beneficiary level file, right? And that is an important distinction, because if you don't convert your claim level file to a beneficiary level file, you might not identify everybody with diabetes. So we go from hospital claims file to an individual level eligible population, and this population, eligible population, will serve as your basis for the rest of the project. Next, the step you're going to do is you're going to attach your RX claims file to this eligible population to get eligible RX claims, and you're going to do that with a left join. But before you do your left join, you actually need to tweak your RX claims file first. You need to add the AWP variable to the RX claims from the NDC file. So we'll take the NDC file, do a left join to add the AWP variable to RX claims. But before doing that, we will also remove duplicates. If you remember, this removing duplicates is something that when I was showing in the video on Friday, week before last, I actually missed that, and we had to add that in later, right? So this removing duplicates you complete here, and then add the AWP variable to the RX claims file, then do your left join to get your eligible RX claims. At that point, I'm saying you group by beneficiaries again, move from a claim level file to an individual level file, beneficiary level file, which has RX claims, and then you join with hospital claims to get the cost variable, get your eligible hospital claims, and then convert that into the beneficiary level as well again to get prescription and inpatient costs, and then you get your analysis file, right? So this basically maps out the steps you are doing. So if you draw this out on a piece of paper before you begin working on that project, you can look at your piece of paper, look at your SAS code, and see steps one after the other, right? And they have to follow in that order. Now, these steps are really helpful for a couple of reasons. One, I would really encourage you to use this if you're just beginning to program, and if you're just beginning to use SAS for health outcomes research or any other projects. These maps are also really helpful when more than one individual is working on a given project. Some projects can be really complex in terms of how much work goes into them, right? I've worked on projects that take a year and a half to program sometimes. When you've got projects that are that big, you have multiple individuals that you have to collaborate with. So having a map, make sure that you communicate well with your collaborators. Having a map also means that you might say, you know what, I'm going to take this left half of the map and I'm going to program this. Why don't you take the right half of it? And together we can put our codes together and get it done. If you don't communicate with clear sections divided out like that through this map, you might end up replicating each other's work, or worse, you might end up forgetting parts of the project itself and not accomplish it very well. Next, using these kinds of maps also helps you practice better programming. Let's take an example. Let's say that as you were doing this, and let's say you did not have a map and you were working on this project, you forgot to do this remove duplicates part, right? You forgot to do this, you added the AWP variable to the RX claims file without removing duplicates, and then you just kept proceeding down the road, and then you realized when you got to this point that you forgot to remove the duplicates. Well, there's a couple ways to fix that. You can actually remove those duplicates and try to fix it right here at this step between this data set and the analysis file and fix it here. But that wouldn't be the right thing to do, because if somebody else is trying to read your code later, it becomes much harder to understand what you're doing here if you do it at this step. But because you've got this map now, when you forget to do something like remove duplicates, this map forces you to go back and add it at this step, not at this step, right? So if you do it here, it's still logical, simple, easy to understand. And if somebody is reading your code and trying to understand what you've done, it's a lot more meaningful to them if you follow this map according to the way you laid this out before you even started programming. So maps like these are really helpful to keep everybody on track. I have found that I don't make maps that much anymore because I've been doing this for a while now. But again, when I am working on a project that involves multiple people and I'm coordinating, I would prefer to work off of maps like this. Some other things you can do when you're creating your projects in SAS is create sections of your project so that not everything is in one program file, right? If you have a really long project, putting everything in one file is a little risky for many things, for many reasons. One, your file itself becomes difficult to read. Two, if you lose a file for whatever reason, let's say you forgot to hit save, or your data set got corrupt, or whatever else happens, right? Or somebody rewrote your file. You are less likely, if you don't use different files, you will have everything in one file and you're more likely to lose all your information, which is not ideal. So I would recommend splitting your project up into multiple program files. And I've shown an example. This is actually a real project that I worked on earlier this year. And this is how we set up the program files. We had one file called one_finder, which has the eligibility information. Then in the second program file, we pulled all the comorbidity information for these individuals. In the third file, we looked at how many times they used the hospital, how many times they went to outpatient clinics, ERs. In this next file, 3B, we actually did Charlson Comorbidity Index. Then we calculated medication use. We did matching, outcomes, and analysis, all in different files. And the way we kept track of these files is the file names started with a number that told us what we were doing and what the order of the files are. So 1, 2, 3A, 3B, 3C, 4, 5, and 6 basically tells you what the order of the files should be if somebody else were to come into this project folder and start working on this project. Creating sections like this into different files also helps you be a better collaborator. It makes quality checks easier. When you are working with so many different files though, you have to carefully plan. You have to go back to this map and you have to plan which parts go into which sections. And then once you have a section ready, you need to decide which data sets need to be saved into a permanent library and which ones can be left in work, right? And the tip that I always use, with some exceptions where necessary, is that when you're dividing your project into sections, always save the last file from one program into the permanent library so that the next code file can work off of the permanent library and that data set off of the previous code without having to run this code in order to run the next code, right? So here's an example of what I mean by that. The file containing eligible individuals from one_finder_v1 is saved to a permanent library so that you can close your SAS session out, finish programming that project, and you or somebody else can pick up SAS again and start on the next file, 2_comorbidities, and all they have to do is to use the last file from the one_finder code, which has been saved to a permanent library, right? So then only the last file, last data set you're creating in a given code file will be saved to a permanent library. All the other files can be left in work and then deleted when SAS is automatically closed, right? When doing this, be careful. Try not to store data sets from two different project sections to the same data set or the permanent library, because if by accident you end up using the same data set names, when you're programming in different ones, you might end up rewriting or overwriting a file. So you want to be careful, and you also want to actually assign different data sets for each of these files. And each different folder can have the files from each of these different code files. So that's another workflow thing that helps make programming a little bit easier. Next, version control and naming. I am really, really particular about version control. It is very important to me and anybody that I work with that we have clear, delineated, and consistent rules for version control. So I'm going to share some of my rules with you guys here. Version control rule number 1, never name a file or a data set final. Nothing is final. In my world, everything is always changing, right? You always have versions depending on where you are on that project. And once the project is complete and once the project is published, you just use the latest version. You still don't have a final version because it's possible you might reuse that data set for another project. It's possible that a reviewer on your manuscript comes back, asks you to make changes. Then you have to create a new version. So whatever it is, never name a file final. The words final should not be in a file name, whether that is a program file or a dataset file. Next, never overwrite original data files. Once you start a project, whether that is primary research or secondary research, always create a copy of your original data file in the work folder before you start doing any other data management. Next, version control. So every time you make significant changes to a program file, please save that as a new version. So in case you want to go back to an old version, that's something you've changed, you will always have those earlier copies. How often you save the file as a new version is actually completely up to you. I will say that I hit Control S or save on my computer every 15 minutes or so. It just automatically comes to me. And then every day or every half a day, sometimes if I've done a lot of programming or if I made significant changes, I will save it. I will hit save as, and I will go save it as a new version number, just so that I'll have different versions. When you're using different version numbers, save your file names either as _v format or _date format. Either one is okay. I prefer _date, but I know a lot of people that use the _v, which is perfectly fine as well. If you are using the _v format, please be sure to use v01, not v1, because if you have multiple versions that go beyond 10, for example, then Windows automatically sorts v11 to come after v1 and before v2. And you don't want that, right? You want v11 to come after v10, not after v1. So to avoid that, always use v01. Easier way to do this is to use date. So if you use the date, make sure that the format of the date you use is date, month, year. So I will save this as _2020.08.01. And I use dots because I could use periods again. Sorry, I could use underscores again, but I've already had an underscore before the date started. So I like using dots, and SAS names don't actually allow hyphens in there. So I have to use periods instead of hyphens. If you use this format of date, which goes date, month, and year, when you actually finish programming, your folder will actually automatically sort all the files so that the latest version of the program file is at the very bottom. So if I go into a project file looking for programs, I know that the file that is at the very bottom of the data set of the folder is actually the latest version. Next, please make sure your data set and variable names must be, in order of preference, number 1, descriptive, number 2, consistent, and number 3, short. Names have to be descriptive. If your names are simple one-letter names like A, B, or C, or things like test1, test2, data1, data2, nobody understands what you're looking at. And if your names are not descriptive, you are much more likely to make an error when you are supposed to be calling on or using a data set or a variable. But if they are more descriptive, it makes life a lot easier. So descriptiveness is the number 1 priority when you are naming a data set or a variable. You also have to make sure you are consistent with how you name them, because if you are not consistent, being descriptive is not really going to be helpful. And then finally, you have to try and be short as well. Long and really long data set and variable names actually get harder to type and it takes too long, and that's not ideal. But I will say that having a short name, in my opinion, comes as the last priority when it comes to naming conventions compared to descriptiveness or consistency. And I will share how I name my data sets in just a second. Finally, when you have multiple words in a name, whether that is the name of a variable or whether that's the name of a data set, you can separate the words in a name either using underscores or using what is sometimes called camel case, right? So you can type ELIG underscore Benny underscore claims, which that name tells me that these are all the claims for individuals that are eligible. So the name is very descriptive, but it has 3 words. So separate those 3 words. You can use underscore, but my carpal tunnel flares up if I have to type too many underscores. So I might alternately use camel case, where I will separate the words out by distinguishing between lowercase and uppercase letters. So my E and the B and the C are capital letters, uppercase letters, so I can see that those are 3 different words. Either one is fine, but make sure that the names are descriptive. Here is the version control and naming consistency that I like to use when I work on projects. All input data for my project, all of my input data sets are actually stored in a library that I always call data underscore in. No matter which project you're in, call it data underscore in. So if you're jumping from project to project because you're working on several projects, you are still using the same library names and you are not getting confused between what to call the data set or the library, excuse me. And all output data that I'm generating and saving to a permanent library should be named in a library called data underscore out. So I know that those are my output data sets. Next, all beneficiary or individual level files should always start with the prefix Benny underscore, whatever it is, right? Whatever comes afterward helps describe what's in the file, but the prefix has to be Benny underscore. Similarly, claim level files should start with the prefix claim underscore. Alternately, you can start them with the prefix hospital underscore or prescription underscore or something else to describe that they are not Benny level files. Next, all analysis files should be stored in a file called dataout.analysis. Your analysis file actually is the most important file that you're going to be generating from your data management, right? It's the last file of your data management exercise, and it's the file you're going to be doing your statistical analysis on. So for every project you work on, there should be only one analysis file, just one analysis file. If you have projects where you have more than one analysis file, then you need to think really carefully about why you need more than one. And if you really need more than one, then you have to label them appropriately. But as a rule of thumb, I always have just one analysis file for every project I work on. And that one file includes all of the variables that I need for my analysis. Every single analysis I need to do on a project should be based off of one file alone and not off of multiple files. And that file should always be called data_out.analysis, meaning it's stored in the library data_out, and the file name is simply analysis. So that when I finish programming through all of these program files, I can then go to this file called analysis, and I can simply start typing proc_freq data equals data_out.analysis, and I can start working on my frequencies or whatever other statistical analysis I want to do. Next, programming efficiency. When working on a SAS program, you are using multiple resources, right? You are using programmer time, you're using workspace, you're using disk space, and those are two different things sometimes. You're also using memory for your computer, and you're using CPU time. Ideally, you're going to have to minimize all of these resources, but in reality, you're often making trade-offs between programmer time, memory, CPU time, disk space, so on and so forth. So what does this mean to be using minimal resources? We'll go over a bunch of things you can do to help minimize your resource use. But the first thing I'll start with is that don't leave your SAS session overnight open or over long periods unless you actually have code actively running. If you don't have code running and you're just done programming for that day, save your code, close the session, go to bed, wake up in the morning and restart SAS. This is particularly important if you're working on a shared server like we do in pharmacy administration, right? We have one server where several people log in to work on. So if you leave your SAS session open overnight, it often slows down SAS for everybody involved. So when you're done with your project, when you're done programming for the day, reach a point that you think is a good milestone, save what you need to a permanent library if you want to or if you have to, and then just close SAS, delete, which automatically deletes all your work data sets and helps free up space for anybody else that may be programming. Some other important notes for programming efficiency. Do not save every file you work on to a permanent library. That just wastes space very easily. When you're working on huge data sets which have millions of rows of data, every time you save a file to the permanent library, you are basically potentially creating a copy of the same file, right? Some of our files are 40 gigabytes in size. So if you do 5 data steps, you've now created 5 40 gigabyte files, which is 200 gigabytes. And that really adds up really quickly when multiple people are working on a project on the same server. So do not save every file to the permanent library. Remember that files can be recreated if you simply save the code and rerun it whenever you need them. In fact, you should be economical, not just with files saved to the permanent library, but even to the work library. Even work files do consume space, right? And if you keep adding files to the work library for a long project over and over again, it can slow down the whole server for everybody that's programming on there. So if you want to avoid doing that, make sure that every few sections of code later or every code file or else at the end of every code file, for example, use the proc datasets command, and you can look up the syntax for this because I know I did not show this during the bootcamp. The proc datasets command actually lets you delete the files in the work library without having to click and delete them. You can delete them through the code. And I actually encourage doing this just to help clear up some workspace and free up memory for all of your subsequent analyses. Next, more tips for programming efficiency. Please use data steps over proc SQLs wherever possible. I know I use a good bit of proc SQLs, but I've met people that almost exclusively use proc SQLs, and I would encourage you not to do that. Proc SQLs take up a lot of memory, and they are more likely to cause errors and are difficult to check for quality issues. So please use data steps as much as possible. Next, anytime you do a proc, whether that's a proc SQL, whether that's a proc sort, proc_freq, please add a quit statement. If you don't add a quit statement, the code will still run, But what SAS will do is it will actually hold on to that file within its memory even after that step is complete, which means you're just using up memory even though the procedure that you need to run is completed. So please add a quit statement every time you write proc SQL. Please add a quit statement every time you write a proc anything, right? Next, for every data step processing, if you are setting a data set and doing some processing on it, please make sure you are processing the smallest possible data file that you need. This means that you have to filter out unnecessary variables. If you're not going to be needing them, if you're not going to be processing them, drop those variables. Next, if there are rows that you're not going to need, please drop them at the beginning of the data step. So write your data set and then write your filter statements at the very top so that you actually delete the rows you don't need before you do any other processing. The larger the file that you process, the longer it takes for your programming efficiency. And these things become important when you're working on big data sets. Some other things that are really important when you consider programming efficiency, and I actually found some really neat little charts to explain why they are important on this presentation that I've linked at the bottom of the slide. When dropping variables, please use your keep or drop statements within the set statement, not the data statement or inside your data step. The reason you have to use them within the set statement is that if you drop variables in the set statement, it actually decreases what variables are read into the PDV or the SAS program data vector. So if fewer variables are read into the SAS program data vector, you're consuming smaller memory space, which means you're more likely to be efficient. If you write your keep or drop options in the data statement or within your data step as its own individual statement, the variables are actually not dropped before the PDV. They are dropped after the PDV processed that row of data, which means the PDV actually held on to those columns of data which you're not going to be processing, which inevitably takes up more memory space, slows down your processing. So please use keep or drop options within the set statement. Next, in order to increase efficiency even more, use where statements instead of if you're just looking to delete some rows. If all you're doing is filtering your data set, the where statement actually deletes those rows of data before they are read into the program data vector, but the if statement actually reads the rows into the program data vector and decides which ones it needs to output after the PDV actually looks at the row. So if you use the where statement, some rows don't even make it to the PDV, which means the input-output processing is actually going a lot faster. You're using less CPU time. The same logic actually also applies to if-else statements instead of if statements, because if you use two if statements on the same variable, SAS will run that condition in that if statement for both if statements on every single row of data. But if you use if then else instead of just an if, the else condition makes sure that only those rows of data which don't meet the condition in the previous if statement are actually processed for the second if statement, which saves CPU time. Same thing goes by for proc sort. If you want to sort a data set, don't write a proc SQL with an order by statement, right? Proc SQLs are laborious and they take a lot of resources, and you should not be using them just to use order by. Please use proc sort instead of order by. And that's all I have on program efficiency. There are many more things you can do when it comes to being an efficient programmer, but many of them are context dependent, so I'm not placing them in this video right here. Hopefully you'll pick those up as you work on projects. Next, quality control. And this is a very important point. Know that the very best programmers also make programming errors. And when I say the very best programmers, I am not talking about myself. I have met a lot of people that have much, much greater programming chops than I do. I only know the amount of programming I need to know to get my projects done, right? But even the best and the very best of programmers make errors because that's just the nature of programming. Syntax errors are usually, the good programmers are good at catching syntax errors and making sure that they don't affect the project. But every programmer will make errors that are not caught by the syntax or the log. And those things are just difficult to catch. So accept that no matter how good a programmer you become one day, you will make errors. And after you accept it, take steps to decrease it and decrease the likelihood of those errors. So the first thing that you have to do is every project, in fact, I think the bullet point is every major project. I would say every project, in fact, that you work on should have at least one independent quality checker that is not you. So if you are programming on a project, find somebody else, collaborate with somebody else, and have them read your code, see if they find any errors. And finally, when you do quality control and quality testing, let's learn some lessons from our software developer colleagues, right? All of the things I mentioned earlier with regard to how to structure your folder, your version control and naming, let's now learn from our software developer colleagues and actually develop two different folders when you do this. We'll call our first folder our production folder. The second folder is our testing folder. Our production folder is where the project actually happens. That's where live versions of code are written, the correct library names, the proof check data sets, they're all in there. The statistical analyses are in the production data set. That's your actual project folder, right? And then we also create a testing folder, which is where all the quality testing happens. So if you are working on a project and your codes are all saved in a folder called production, you'll have a colleague come in and proofread your code, but they won't just proofread it in the production folder. They'll copy and paste that program file into another folder called testing, and there they will do their proofreading, right? So when they do their proofreading in the testing folder, they will reroute their library name statements so that they will duplicate the data sets within the testing folder, so that as they run that code while proofreading it, they don't accidentally overwrite a data set that's in the production folder, right? So that way we can make sure that quality control doesn't actually affect the program itself in the production, but thorough quality control is also happening. And every time you catch an error in quality control in the testing folder, make sure you fix the error first in testing, see what fixing the error does, make sure that the fix you incorporated is accurate and correct, and then copy it over into production. So having these two layers as you're doing quality control will make sure that you are actually following best practices. And this is something that I've learned from friends of mine that are software developers, and they do this for most of their projects, their websites, and their apps that they're designing. And I think we really do have some lessons to learn from them. Next, and this is the last thing I'm going to say, always write your code as if it will be made publicly available or shared on your friends, on your office door, whatever fits you better. But write your code as if it will be made publicly available. If you think nobody is going to read your code except you, you are not likely to add comments on it. You're not likely to make sure that you have sections or your variable names or data set names. You won't put effort into these things. But if you write your code as if your code will always be made publicly available or shared with other people, that will make you, that will encourage you to follow better programming practices. I will wrap up with that. If you have any questions, please let me know. Later this week, I will also be sharing our class project solutions and the code for that and the solution for that project. So I will see you all on Friday. But this is the last video we are going to make for content of this SAS Bootcamp. So I hope you've learned something. I'll connect with you all later. Bye.